Okay. Now let's start a new. We know that your book have a lot of units. This book. Okay, I think I want to write. I will open it for you. Now, see here. Today, now we're going to start with a new module in Unit 1, which is Module 2, Lesson 1. That's talking about the conditional statements. As you have conditional statements in English, you have conditional statements in math. In this lesson, we're going to learn how can we write the conditional statements and the related statements to the conditional one. Now, what do you mean by conditional statements? Conditional statements, as you talked before in English, like if you say, if you have a job, then you have a college education. So it must have two letters, two words, sorry. If and then. If you are hungry, then you must eat. If Cliff is thirsty, then she drinks water. This is what we call it conditional statements. Now let's go to math. Here now, we have to write the conditional statements from the description. What do you mean? Sometimes, like, you say that if there's a shape that has 4 sides, then this will be rectangle, or this will be square, or this will be quadrilateral, and so on. Or another one, if you have a shape with 5 sides, then this will be pentagon. This is like a conditional statement in math. Now, here before that, let's remember, before talking about how to write the conditional statements, let's remember something we call the postulate. As we talked before in Module 1. Postulate is a statement that's proof that is accepted without a proof. Sometimes, later on, sometimes when you learn a new theorem, I ask you have to prove this theorem. But there's some things like this one here. Throw any 2 points, there's a line. If you have 2 points, throw them, you have exactly only 1 line. This is what? This is a postulate. This is a statement. It's correct. It's yes, it's accepted, you can say, but without the proof. No need to prove it. And today now, we have to learn something we call it counter-example. Counter-example means that this is an example. You prove that, teacher, but this is not necessary work. And as an example, I told you that I am from, I lived in Saudi Arabia. Okay? Then I live in Saudi Arabia, then I live in Riyadh. Now, it doesn't matter. Maybe you live in Jeddah. So these examples, we call them counter-example. That you give me example, tell me, teacher, no. This statement sometimes doesn't work. Let's take now some examples about, later on we will talk about the postulate, more examples for the postulate in geometry. But let's talk about the counter-example. Counter-example is an example used to show that the statement is not always true and sometimes could be false. Like these examples here. One of them, as I told you, if you live in Saudi Arabia, then you live in Riyadh. No, you tell me, teacher, no, it's not necessary. Sometimes you live in Saudi Arabia, but you live in Tabuk. Another example. If a fruit is if a food is a fruit, so this is an apple. You teacher, no. The food is a fruit, but it's not apple, it's a mango. Yes, bravo. But if you change it, like you need an apple, so it must be fruit. It cannot be vegetable. How what? You didn't understand what? Can you tell me better? Counter example? Counter example that I tell you something, and you tell me, teacher, no, it's not working. It's not working. How can you live in Riyadh and you live in Saudi Arabia and you live in Riyadh? Maybe you didn't live in Riyadh. And I told you that if I live in Saudi Arabia, that means I live in Riyadh. But there's only Riyadh in Saudi Arabia? No. There's maybe Tabuk. So you tell me the counter example, you give me an example that you prove that, no teacher, your statement is not always true.
I live in and Saudi Arabia, so I say Saudi Arabia, so I didn't say where I live. Like you mean I say Saudi Arabia, but I'm living in Tabuk.
Here you give me conditional statements. And you say, if I live in Saudi Arabia, that means I live in Riyadh. Yes, it must be that I live in Riyadh. This doesn't work. Sometimes I can live in another place. Like this one here. I told you now, if you have hair, then you are a human. But some of you tell me, no, teacher, the bear have hair. So this is not acceptable. Sometimes you tell me, teacher, no. Sometimes you have an example that tell you that your statement is false. This one, we call it counter example. Now, did you understand what's the meaning of counter example?
Yes.
Let's see now how it's working in math.
Oh, but if I said, I went to medical school. Actually, I'm a doctor.
Can you repeat it? If I
went to medical school, that means I'm a doctor. What is that?
Then I will be a doctor? Yes, this is conditional. Because in this medical school, you have learned here how to be a doctor. Counter example, it's not a statement. It's give me an example. Tell me, teacher, no, your statement is not working. No, it's an example. Hey, counter example. Okay? This is an example. Tell me, teacher, your statement is not correct.
So the example say that no, your statement
is not correct. Yeah. Let's see how they're working in math. Now, all of you, please, I want you to work on your paper. Let's start now. I told you what is the postulate and what is the counter example. Let's start now with the first postulates of geometry. The first one says that through any 2 points, there is exactly one line. Okay? I want you now to draw it on your paper. What do you mean? Draw a sketch that demonstrates that through any 2 points, there is exactly one line. Put 2 points, throw them, make one line. That's it only. Yes? This is the postulate. So this is what the postulate. It is a statement that is accepted without a proof. 2 points, draw a line between them, you make a line. Let's see now here. That's it, like this. Draw only 2 points, there's a line. Now, can anyone give me an example? Tell me, teacher, this is not, maybe that's not correct.
If I put another point, it will be
for this statement only. Can anyone give me that from 2 points you can make not only one line, you can make 2 lines? No, 2 points, and you can make 2 lines between them. No. 2 points and 2 points only, and make them and make more than 1 line between them. Can you? Yes, yalla, tell me how. It's not line.
Teacher, yes, you can, teacher, because you can put 1 point in the middle, and there's gonna be 2 now, 2 lines.
No, but this is you put 3 points. I told you throw 2 points, you make 1 line. Can anyone give me an example, a counter example? That cannot work. No, it can't. It is possible to draw a counter example. No, you can't. Why? Because there's no way to draw two different lines going through the same pair of points. This will be in which one? Page 42. Okay. So can anyone give me a counter example? Can anyone give me example, teacher? This is not working? No. Right. Right now. 2 points. How? Wait. Yalla, did you finish? Yeah. Yalla. From now here, the second postulate. Throw any 3 non-collinear points. What do you mean by collinear? Here, and here. 3 points that are not non-collinear points. There is exactly one plane containing them. Non-collinear, I mean 3 points, not on the same line. Yes, here and down, as an example. Throw them, you can draw one plane. I want you now to sketch in your book. Yeah, we can. From rhythm. I want you now to sketch it in your book and tell me if you can do an example. Teacher, this is not.
If it's collinear, it's gonna be coplanar because if you want to make a plane, all of the planes, not all of them on the same line.
Yeah, I told you that they mustn't be on the same line.
Teacher, the one before the 2 points between the exact one and
the first one, collinear, yeah. But this is not collinear. I'm not asking you to write collinear or coplanar. This is only postulate. That's okay. Yeah, let's now see the sketch.
Wait.
I told you, collinear, that means 3 points on the same line. Here. Non-collinear, not on the same line. If you draw a plane that contains them, you make only one plane. I want another one. Teacher, tell me no. Teacher, maybe it's make 2 planes.
It makes none. If it's not collinear, it's gonna be on the line.
One plane.
Plane. What's the plane? What is the plane? Have a plane?
This is the plane, like the board.
Like this. It is already a plane. Teacher.
Do you understand what? Right. All right, please, Allah, you understand. Let's stop, teacher. Let's see. Stop, see. Play here.
What?
What's this? This.
It is for D. Draw a sketch that didn't.
No, I make something wrong. Just a minute. No, this is false. I will draw it for you. This one is not related. Just a minute. No. No, this is wrong. What by mistake? Okay, I understand what I did. Just a minute. This postulate is not related to that one. That's me. Just a minute. Just a minute. Shannon, that's your word. Your watch is not correct. How it's 15 minutes? 20 minutes.
Teacher, I still didn't get you said anything on continuous
Yeah,
points.
let's continue here now. So if you have three coplanar points, one,
Where are you put my head? My shit. No,
so three. One, two, and three. Okay? Draw any three non-collinear points. You can draw exactly. That's it. So hi, 3 points. 1, 2, and 3. Astaghfirullah al-Azim ya Rabbi. I cannot find my hand.
2 points between 3 lines. Why can't I understand? No, I can't play teacher. خلاص دي teacher, it's false.
That's true. How false?
How? It's 3 collinear points between one collinear. No, بس ما في between them one line.
Not one line. No. See. Look at this one here, but forget this line. Okay? Here you have 3 points. And the 3 points are not in the same line. For them, can you draw only one plane? Yes. Can you draw only more than one plane? This is the plane. Plane like the board, like the wall. Okay? So, can anyone give me a counter example? Or give me an example. Say that this is not always correct.
Yes. No, I think this is correct. Because the teacher says through. And it's through them. Not around them already.
Okay, all through them. Can you make more than one plane?
No, yes, I can't make one plane.
Only one, more than one. No, you can't. Yeah, tell me.
1, 2, 3.
But it's okay, more than one. Can you?
Yes, and only 3 points.
So, this is a postulate, and you cannot give me an example. Now, this one here. There's a postulate says that throw. Just right here. If there's 2 lines intersect, the lines intersect in exactly 1 point.
Yes.
This is a sketch. Okay? 2 lines. When they are intersected, they must intersect in 1 point. Can anyone give me an example? Shows that if there's 2 lines intersect, they can intersect in more than 1 point. 2 lines, if they are, imagine now 2 lines, if they are intersect, they can be intersect in. What do you mean by intersect? Intersect. Yes. Can they cross in more than 1 point?
No.
No.
Because they're already intersected. How are they going to intersect?
So, if it is it possible to draw a counter example?
No.
No. There's no way to draw 2 lines that they intersect more than 1 point. Up to now, is it clear? 2 lines, I think. Do you have any questions? Fine. Now here, let's talk about more postulate. If 2 points lie in a plane, okay? Just tell me, just tell me.
What do you call this one? That we're going to lie on what?
Yes,
Just the time.
it's a plane.
Teacher, I have a question.
Yeah, so you can make more than one plane. لا plane. لا, it's a plane. It's not a line.
Teacher, I have a question.
Yes.
Teacher, now when you said through any three non-collinear points, there is
Eh?
exactly one plane containing them. I didn't understand it.
I cannot hear you well. Can you send me a question in Telegram?
Okay, teacher, just a second, I'll send it.
Can you send me a question in Telegram?
Okay.
You're feeling bored. Wallah, you can go away. Yeah. Now, draw a sketch that demonstrates these statements. The first one, we talk about it, like here. Throw any three non-collinear points, there's exactly one plane. The second one, if 2 points lie in a plane, okay, the line containing them also lies in the plane. Draw it. I will repeat. If 2 points lie on a plane, okay, then the line containing them must be in the plane.
But it can't be. I thought it can be. It's only one line.
Plane like the board. Yes.
Okay, teacher, but how? If it's a
This is
one
for what?
line and all of them are collinear, how is it a
For
plane?
which intersecting?
Oh, no, it's like the plane. It's like the
Okay, 2 lines.
The line have 2 points.
Okay.
one line.
The line have 1 point.
Oh yes, they intersect. But where did they intersect? At which point?
At the 3 points.
No, intersect, what does it mean? Intersect يعني يقطعوا بعض. Where did they intersect? At which point?
What is this? Is this not a line?
At this point.
Here.
And she said 2 points.
Here they cut each other.
Whoa, I want to see.
Got it? 2 planes. Where did they intersect each other? Here, look at me. This line and this line. Where did they intersect each other? Bravo. So, can it intersect in more than 1 point? No. So, it's exactly 1 point. Yalla. So, here. Yeah.
Line with a line segment. There's not even any
Line.
It can be like this.
It's
If 2 points lies on the plane, the line containing them also lies. Okay, it is also lies on the plane. Oh no. But it still be in the plane. So it's like this. If 2 points lies on a plane, then the line containing them must be on the plane. Oh. Like this, yes. Oh.
Where did you bring it from? Google.
What?
No, but I don't know.
2 points. Just a minute, please. 2 points. Okay? They told me that if there's 2 points on the plane and you draw a line between them, that means the line is on the plane. Is it okay? Is it true? No, it's okay. That's okay. Fine. Now the third one. It's already drawn. Yeah. If 2 planes intersect, what do I mean by 2 planes? Like this plane. This is a plane. Give me this one. This is a plane and this is a plane. If they are intersect, where did they intersect? And let's make a line. So if 2 planes intersect, then they intersect in exactly 1 line. So remember, if you have two lines, they intersect in 1 point. But 2 planes, they intersect in 1 line. Like this one here. This is a plane and this is a plane. When they intersect only in 1 line. It's okay, it's 1 line.
If it was like this, it would be wrong.
How? It's intersect only in this line. How they intersect here?
They intersect here in this line.
Well, it's the same line.
From down.
Well, it's the same.
From the same angle.
يعني here or here or here or here. It's the same.
It looks like
So don't forget, two lines are intersecting. Where do they intersect? Two lines in one point. And two planes, if they are intersecting, where did they intersect? In one line. Can anyone give me another example, statements or example that's not work?
two planes intersect.
Well, because this is a postulate.
This is even. It has all the signs. Like this, it is multiplication. Like this is addition. Without the first one, it's minus, and this is division. Don't change this one.
So, yeah. No, come here. That one. Yeah. So shall I go now? Billah. Well, why you say 10 minutes left? Yeah. Now, so if it is, or is it possible to draw a counter example of any of these statements? No. Now, let's now go to talk about how to write the related conditional statements. But before that, let's remember, or let's talk about the conditional statements. As I told you, conditional statements, it must have two letters. Two words, sorry. If and then. If this happens, then that will happen. The first part after if word, we call it hypothesis. And the part or the statements after then, we call it conclusion. If this happen, or if this happen, then this will happen. Conclusion. Okay? So the word after if, we call it hypothesis. And the word after then, we call it conclusion. Hypothesis and conclusion. Hypothesis, what does it mean? The theory, you can say, or the statements, or the cause. This is here the conclusion. That will happen. Let's have other results.
So that's why it's written SP and Q is the conclusion.
Just wait. We want to talk about later on.
It's in the book with teachers.
Yeah. Okay. Now later on you will find that P is the hypothesis and the Q is the conclusion, but we will read it. I will tell you. Now let's talk examples. If today is Thanksgiving, then today is Thursday. Where is the hypothesis? After if. Today is Thanksgiving Day. If this happens, so this means Thursday. So today is Thanksgiving Day. This is an hypothesis. After then, today is Thursday. This is a conclusion. The second one. If a number is an integer, then it is a rational number.
Yes, true. And number is a.
Where is the hypothesis?
A number is an integer.
The thing that if it is happen, then it will happen. If the number is an integer, like number 5, then this must be a rational number. And you must know what I mean by rational number. That's we talk about it in the first semester. Where's the hypothesis? Number is integer. Where's the conclusion? It is a rational number. Is it clear? Now, this one here. A number is divisible by 3 if it is divisible by 6. Now, wait. I want you to identify the hypothesis.
A number is divided by, if it is divided by 6, it will be a number divisible by 3.
What do I mean by divisible by 3?
You can divide by this number.
Like number 9. Number 9 can divide by 3.
Yeah.
But number 9 cannot be divided by 6.
But number 6 can be divided by 3.
But, so this, I cannot say that if a number is divisible by 3, then it's divisible by 6. Why? I cannot say this. Why? Because 9 can be divided by 3, but cannot be divided by 6. But number 12,
Can be divided by
number 12, it can be divided by 6. And any number that is divided by 6 must be divided by 3.
Yeah.
No, remove half of it. I give you an example. Like number 36. Yeah, 36. It can be divided
Teacher, for
by 6.
example, number 18.
Sorry?
For example, number 18.
Number 18. It can be divided by 6 and it must be divided by 3. So how I will write it?
Teacher 24.
If it, no, it is from me, divisible
By 6.
6, then the number divisible by 3. So in your workbook, it's not this. Just a minute. In your workbook, sometimes they give you examples like this. You have to understand them. You have to tell me where is the hypothesis and where is the conclusion. Which one? It's must. Well, if it's happened, then it will happen. It's not written. So what is the hypothesis?
If it is divisible,
Bravo. This is the hypothesis, and this is the conclusion.
because you have one.
Yeah, this is because you have word then. This will be the conclusion, and this will be the hypothesis. But you must know how to write the conditional statements. The first part we call the conjecture. Conjecture means it's correct. But how I will write as a conditional statement? Conditional statement, it must have if and. So you must repeat your, or you can arrange your ideas, you arrange your thinking, how I will write it in a conditional statements. Got it? Yeah, Miss White. Now look at the second one. Two angles that are complementary are acute. No, I want you to write the conditional statements.
Oh, if
Let's start. This sometimes you have two statements here. The first one, two angles are complementary, and the second one, acute. Which one? If it is happen, the second one will happen. If two angles are complementary, then they will be acute. Or if
two
angles
acute,
are
they will
acute, they must be
complementary.
Acute, then they will be complementary.
What did you say?
If they are active,
If
they
two
will be
angles are
complementary.
acute, then they will be complementary.
If two angles are acute, that means they are complementary. Which one is?
if two acute angles,
The last time. Next time, what I will give people.
if two angles are complementary, they are acute.
So which one is must be? If two angles are complementary, then they will be acute. Or if two angles acute, then they will be complementary. So if two angles are acute, then they
Be acute. I mean, they will be complementary.
So where is the hypothesis? Two angles are acute, and the conclusion, they must be complementary. Do you have any questions? Okay. You didn't understand? What you didn't understand? Well, you have to think about it. يعني think, ask yourself. Two angles are acute, then they have to be complementary. Okay, like 30 and 20 and 70. Okay, both of them are acute. So because they are acute, so they must be complementary. Okay, but if they are if they are complementary, they must be acute. By the way, this one later on we call it biconditional. And this must be the first one, we hypothesis, and or the first one will be. Another example, I mean, like sometimes if two angles are complementary, like 10 and 80, they are complementary and they be acute. So they must be. This we call them later on biconditional. Biconditional, and if you change the order, it's working. So you can say this is the hypothesis, and you can say the first one is the hypothesis. Like this is, you can say two. I call them biconditional. Later on, we will talk about it. If you change the order, it's still working. Okay. So where's the hypothesis? The first one. You understand how? That's it. The second one is more complicated. But here now. Yeah, this one. If you want to buy a book, if I want to buy a book, then I need some money. Where's the hypothesis? Where's the hypothesis? This is the hypothesis. Where's the conclusion?
I need some money.
This is the conclusion.
I need 100.
If today is Thursday, then tomorrow is Friday. I know it's true. Where's the hypothesis? This is the hypothesis.
If today is Thursday, it's the hypothesis. And
Then
then
tomorrow
tomorrow
is Friday is what?
is the conclusion.
Right here. Call your parents if you are running late. أيوة bravo. If you are running late, I will call your parents. I will not call your parents if I want. If this happens, if you're coming late, I will call your parents. But I didn't call your parents if I want. So this will be the hypothesis. أيوة bravo. This is, and this will be the conclusion. Okay? If there's anything here? Type this one, yalla. If 4x plus 7 minus 15. This is number 7, 8, and 9 in your book, okay? The first one, 4x plus 7 minus 15 when x. طيب خلاص اوكي.
Teacher, can you hear me well now because I have a question? Teacher, I have a question. Can you hear me?
No.
It's this one.